Welcome back to Algebra. We are in section 4 of chapter 5, again for day 2. This is day 2 of writing linear equations in standard form. And before we get into the second topic, could you please try answering a few quiz questions here? Write this in standard form. Pause the video, select your answer, and come on back. And when you transform this to standard form, you subtracted this, right? And it ends up negative 5/6x. So that is not an integer coefficient. So what did you multiply by? You multiplied the whole equation by 6, the denominator, right? So you end up with negative 5x plus 6y, or the answer is A. Negative 5x plus 6y equals 18. The entire equation had to be multiplied by a factor of 6. And go ahead and pause the video and come back when you're ready to answer this question. And this kind of takes up the topic that we have today. We have $2.25 per pound and $1.90 per pound. So $2.25 per pound is a rate and $1.90 per pound is a rate. And if we only know how many pounds of each, we could multiply them and determine the total. So your answer here is C. Once again, try number 3 in standard form. Once again, you would have to subtract negative or 3/4 x from both sides, and that then would be negative 3/4 x, which is not an integer, so you would multiply by the denominator 4. Multiply the whole equation. So you would then end up with what? Negative 3x? Well, I don't see that possibility here, right? So we could transform the equation a different way. We could multiply the entire equation by negative 4, right? If we had negative 3/4 x, again, move to the left side, we multiply by negative 4, we would end up with a positive 3x. It would then turn our y value into a negative 4y. Don't forget, you would multiply the negative 5 as well, equaling 20. So the correct answer is B. Did I say? I think that is, yeah. All right, and here we go again, question 4. Pause the video, come on back. And so your correct answer here is C. Good job. And in question number 5, pause and come on back. And your correct answer here should be D. Okay, so today let's first start by looking at special case linear equations in standard form. So horizontal and vertical lines are special cases, right? And we know that a horizontal line, imagine that it looks like the horizon, right? Very flat, right? We know that the slope of something that is flat like that equals 0, right? So if we were to input 0 as our slope, we would have 0x plus by equals c. So that wipes out the 0 term, or the x term, doesn't it? Every time. So we could isolate y, right, by dividing both sides here by b. So y is always going to equal some constant, and we call it the constant a. Okay, so imagine in this coordinate plane, and you may need to pause the video and draw this so you have it. Imagine we have this horizontal line here. If we were going to write the equation for that line, could you do it? And in the past I said name 2 points, right? Any 2 points. You could name this point 0, -2. And we could name this point, which is at 2, -2. So they both have the same y value of -2, as do all the points on the line, right? So we could name this line y equals -2, right? Okay, with our vertical lines, we actually have that. What slope is that? Do you remember? That's right, it's the undefined slope. So M is undefined. It's all rise and 0 run. So we have that 0 under the fraction, so it's undefined. And in these cases, instead of y's being all the same, look at the y's are all different. The value that is the same at every point here is the x. All x's are the same, right? In this case, we have x's are at 1, 2, 3, 4. X's are at 4. All of them are. The equation then is x equals 4. So our model is that x equals some constant b. Okay? So standard form, horizontal and vertical equations don't really look as complex as standard form equations that have a slope, right? And so let's recall standard form, the model of standard form together. Ready? AX plus BY equals C, right? So you can see that our horizontal and vertical lines look far simpler. Okay, we are asked here to write an equation of the horizontal and vertical lines that pass through this point. So, as much as graphing takes us time, we could graph this, right? So -8, -9. Let's see, start at 0, 0. Travel -8 and -9. So here's the point. -8, -9. All right, so if we were going to draw a horizontal line through the given point here, horizontal, which way is horizontal? Oh yeah, like the horizon. So we would be going this way, right? All the way across. And whoops, it's kind of hard to do without my smart board, but imagine it going infinitely this way. So if we were going to write this equation, we could just look at any 2 points, right? And when we look at our known point, we have it here, -8, -9. This next point over is at -9, -9, right? So both of these points have the same y value. So the equation for the line would be y equals -9, right? At all locations on the horizontal line. Now the vertical line going through this point would be straight up and down, right? So the y values are all different here, but what values are all the same? That's right. Every x value is here at -8. So to write that equation for the line, we would write x equals -8. Very good. Now see if you can do that. Can you write the equation of the horizontal and vertical lines that pass through this second point? Pause the video, come back, and share your answer. Okay, if you're back, we could start by writing let's write the vertical line this time. X's all would equal 13, right? And you'd have a vertical line at x equals 13, and y's for the horizontal line would all equal -5. So you can see, as long as you understand the concept, this is a simple task, writing an equation of horizontal and vertical lines. Let's try something different. How about finding a missing coefficient in a standard form equation? So in this case, we're given an equation that is just incomplete. We're being asked to fill in the coefficient. That's the number that is sharing this variable. Co-sharing, right? This variable. We're asked to try to find A. And we know that this is the given line. Okay? And we actually have a known point on the line at 2, 0. So what could we do to find A? And think. Let's see. Well, we could take the known point and do what with that? Plug it in, right? Yay, we could plug in 2, 0. And if we do that, let's see what's left. We have A times 2, right? Could also be written as 2A using what property? Commutative. Good. And then for our y value, we have 0. So 4 times 0, okay, equals 6. When we plug in this known point, how many unknowns remain in the equation? Just one, yay! When we have one unknown, we can solve for that unknown, right? 4 times 0 is simply 0. So we have 2a plus 0, that's 2a, right? Equals 6. And what operation will we use to find a? Good. Divide both sides of the equation by 2. So we end up with 1a equals 3. Very good. So we can now rewrite this equation as 3x plus 4y equals 6. Very nice. Okay. So under the box we have substitute a known solution into the given equation. 2, 0 is a solution, right? A point is a solution. And then solve for a. Excellent. Okay, we can do this again. Let's go ahead and try this with 2 equations and a given point. Right? So go ahead and pause the video and come back and share your work. All right, for question 5, we simply plug in -1 for x and 1 for y, right? And when we do, we now can solve. -4 times -1 is 4. 4 plus b equals 7. So we can subtract 4 and b equals 3. Good, we found the unknown coefficient, 3. And again, when you're ready, here is number 6. So what do? We plug in 2 for x and 11 for y. So in this case, what will we do next? Good, we're going to subtract 11. And we have 2a equals -14. And to finish it, we're going to divide by 2. And a equals -7. Great job. Okay, one final question for you, and that is, how can we solve a multi-step model or a multi-step equation in standard form? So once again, once they say standard form, we begin with the standard form model, ax plus by equals c. And here is a great question. T-shirts cost $4.50 each, and shorts cost $6 each. You have enough money to buy 12 t-shirts and 9 pairs of shorts. Write an equation in standard form that models this. And then down below it says, graph it and name 2 combinations of t-shirts and shorts that you could get. Okay? So we see some valuable data here, right? And what do we notice about $4.50 each for the t-shirts? And shorts are $6 each. Wow, we notice we have not 1 but 2 rates. So this is where the standard form equation is super helpful. We use it in problems where we have 2 rates. One rate could be A, the other rate could be B, right? So we could say, let's start with $4.50. T-shirts are $4.50 each. We can write that short like this, 4.5 dollars, right? Times the number of t-shirts. So X will be t-shirts, 4.5x, plus we're going to add $6 each. So 6 is like a second slope, huh? Times the number of shorts. So shorts will be Y. So shorts are Y, I'm going to note it up here. T-shirts are X, okay? And we have enough money, we have enough money to buy 12 t-shirts and 9 pairs of shorts. Interesting. So once we buy t-shirts and shorts, we're going to have some total, which we could call C, right? That's the total cost. So to find how much money we have, we can use this known ordered pair, right? We can plug in 12 t-shirts for X Okay, so we have 4.5 times the 12 t-shirts, and then we can plug in 9 pairs of shorts, right? So 6 times 9. And we're going to find out how much money this person has to spend on t-shirts and shorts total. Okay, so go ahead and calculate. All right, so 4.5 times 12 is actually 54, isn't it? And for the 6 times 9, we also have 54. Okay, so the total cost, or the total amount of money that this person has is 54 plus 54, and that would be $108, right? 108 is our C. So we now have enough information to write this equation, right? We have 4.5x plus 6y equals 108. Okay, so graphing it, we have some choices, don't we? This is a linear equation, and so we simply need how many points to graph it? That's right, we need 2 points. So let's start with, what if we plugged in 0 for x? Let's use our intercepts. If we plug in 0 for x, 6 times what equals 108? That's right, 6 times 18. Okay, and if we plug in 0 for y, then 4.5 times what equals 108? And that's 24. So based on this, we can start at 0 and walk 18. Notice each blue line represents 2 units. And we can fly 24. Ooh, that's a little higher than on my graph, which has 20, so 2, 4. And there we go. Whoops, I actually graphed that wrong, didn't I? I have that in reverse. Back it up, back it up. Let's go walk 0, fly 18. And then we walk 24, right? Way out here, walk 24 and fly 0. Okay, good. Got that corrected. And then we simply draw the line. All right, so there's our graph, and we probably would never enter the second quadrant because we would never have negative numbers of t-shirts, right? And we also wouldn't drop below the x-axis because we wouldn't have negative amounts of shorts. So anyway, we'll probably be a segment in this case, and we're going to name a couple of combos. So let's say we bought, it looks like if we bought 18 t-shirts, we would probably buy 4 pairs of shorts. So there's a combo, 18, 4. And secondly, we could say if we bought, I'm looking for an intersection, so it looks like if we bought about 2, 4, 6, 8 t-shirts, we could have about 2, 4, 6, 8, 10, 12 pairs of shorts. Notice shorts are here, t-shirts are here. So we could just name any pair, any point here, and that would be a combination. Okay, so there you go. Don't forget your quiz tomorrow.